Hi, welcome to our channel of IGNOU audiobooks. Indira Gandhi National Open University, School of Continuing Education, Certificate Programs, Certificate in Nutrition and Child Care, CNCC, CNCC-1 Nutrition for the Community. BLOCK-4 Effective Utilization of Food Resources, Unit-15 Food Preservation and Maximization of Nutritional Benefits. 15.1 Introduction. In the preceding unit we have talked about how and why foods get spoiled and the methods we can adopt to prevent or minimize such spoilage. In this context, our discussion was mainly directed to measures that are necessary to keep food in healthy and normal conditions for short periods, i.e. between the time of harvesting, manufacture or slaughtering to the time of consumption. We shall now, in this unit, direct our attention to measures we can adopt to keep food healthy and normal, or as nearly so as possible, for longer periods of time. The term used for such measures is preservation. We shall discuss the different principles and methods of food preservation with examples of home-scale food preservation. We shall also talk about how one can get maximum food value from the foods we consume, prevent loss of nutrients and avoid wastage of food. Objectives. After going through this unit, you will be able to list the principles of food preservation, identify the various methods of preservation of food, preserve the foods you need to or would like to for future use, and get the maximum nutritional value from the foods you buy. 15.2 Principles and methods of food preservation. The basic principles of food preservation are to either kill or to inactivate or control factors which are the main causes of food spoilage. These factors, as you know, are the growth of microorganisms and activity of natural enzymes. We can either destroy these microorganisms and natural enzymes or keep their activity and growth under our control. We shall discuss each of these under the following headings. Prevention or delay of decomposition by microorganisms. Prevention or delay of self-decomposition of food by enzymes. 15.2.1 Prevention or delay of decomposition by microorganisms. This essentially involves controlling bacteria, yeasts and molds by either inhibiting their growth and activity or by destroying them. Creating an environment in which microorganisms are not able to grow and function although they are not dead is called a bacteriostatic method. Dehydration, pickling, salting, use of sugar, smoking, and freezing are examples of this method. The other, in which you kill the microorganisms, is called a bactericidal method. The use of chemicals and irradiation are methods by which bacteria are killed. You shall learn about these methods in section 15.3. Each one of these techniques can also cause spoilage of foods from the point of view of appearance and/or nutritive value. Therefore, it is a matter of balance. There should be enough heat to kill microorganisms but not destroy the food value and alter its appearance drastically. Similarly, if chemicals are used as preservatives, there should be enough chemicals to inhibit microbial growth but have minimum adverse effects on nutrients in the foods or on human health. You have to strike a balance between rendering food safe, preserving the nutritional value of food and minimizing hazards to human health. The methods and the degree to which it is applied must accomplish all three. Let us look at some of the common techniques used for preservation by this method. A. High temperatures. Most bacteria, yeasts and molds grow best in the temperature range of 16 degrees, 38 degrees Celsius, 60 degrees Fahrenheit to 100 degrees Fahrenheit. Most bacteria are killed in the range of 82 degrees minus 93 degrees Celsius, 180 degrees Fahrenheit to 200 degrees Fahrenheit, but in the form of spores. Many bacteria are not destroyed even by boiling water at 100 degrees Celsius, 212 degrees Fahrenheit, for 30 minutes. You need to use higher temperatures under pressure to destroy bacterial spores. Foods high in acid content like tomatoes or orange juice need not be heated as severely because acid increases the killing power of heat. A temperature of 93 C, 2000 F for 15 minutes, for example, may be enough to sterilize food in the presence of sufficient acid. We must also keep in mind that it is not always necessary to destroy all microorganisms and produce a sterile product. A sterile product means a product that is free of microorganisms. You may need to use only enough heat to destroy disease-producing organisms in food. This is the case with pasteurized milk. The term pasteurization refers to the process of heating the milk at 62.8 degrees Celsius, 145 degrees P, to kill the microorganisms. Most of the bacteria and all of the disease-producing organisms present in the milk are destroyed by pasteurization for 30 minutes. However, the milk does not become sterile, nor is it necessary for it to become so, since it will be stored in a refrigerator till distributed and consumed within a few days. In the case of condensed milk, which remains inside a tin for perhaps years, a much greater heat treatment is applied to ensure total sterility. This, however, also changes its appearance. B. Low temperatures. Although most bacteria, yeasts and molds grow best between 16 degrees minus 38 degrees E, 60 degrees to 100 degrees Fahrenheit, there are some that will grow at 0 degree, 32 degrees Fahrenheit, or even below. However, below 10 C, 50 degrees Fahrenheit, the growth of most microorganisms is slow and becomes slower as the temperature gets colder and colder. This is the reason why most foods stay in the refrigerator for longer than they do at room temperatures without getting spoiled. This is also the reason why one can keep certain food items for months by freezing them. It is, however, important to realize that while cold temperatures slow down bacterial growth and activities and may kill some bacteria, cold, including severe freezing, cannot be depended upon to destroy all bacteria. Cold storage and freezing do not sterilize foods, and when the frozen food is thawed, the surviving organisms often start growing very rapidly. Why? This is because the food structure may have been somewhat weakened by the cold or frozen storage. Thawing, as you know, refers to the process of bringing the frozen food to room temperature. C. Drying. Normal growing microorganisms contain more than 80% water. They get this water from the food they grow upon. Removing water from the food will cause the water from the bacterial cells also to come out, bringing bacterial multiplication to a stop. Bacteria and yeast generally require more water than molds. Therefore, molds often grow on semi-dry foods where bacteria and yeasts cannot grow. Examples are molds growing on stale bread and partially dried fruits. Drying. Therefore, protecting food from spoilage by microorganisms. However, like freezing, even complete drying of food does not cause the destruction of all microorganisms. It may actually preserve some microorganisms like it preserves food. Dried food, therefore, is generally not always sterile. While bacteria will not grow in dried food, the moment moisture is intentionally or unintentionally added, bacteria starts to grow. D. Acids. Microorganisms are sensitive to acid. Some are much more sensitive than others. The acid produced by one organism during fermentation will inhibit the growth of another. This is the principle of using controlled fermentation. The acid produced by fermentation will not allow the growth of other organisms. Acids may be added directly to foods as chemicals. For example, citric acid and phosphoric acid added to beverages like carbonated drinks, or may be produced in foods as we do in making curds. Several foods such as tomatoes, citrus juices and apples contain natural acids. In each case, the acid has varying degrees of preservative power. As mentioned earlier, acid combined with heat makes the heat even more destructive to microorganisms. E. Sugar and salt in high concentrations. Bacteria, yeasts and molds have cell membranes. These cell membranes allow water to pass in and out of the cells. Do you remember reading about the principle of osmosis in school? Let us recall the principle of osmosis. Here, it says water always moves from the side where it is present in high concentration to the side where it is in low concentration. Figure 15.1. Active microorganisms may contain more than 80% water. When they are put in a heavy sugar syrup or in strong salt water, the water from inside the cells moves out into the concentrated syrup, causing partial dehydration of the cells. It interferes with the growth and multiplication of the microorganism. Yeasts and molds, however, can tolerate this dehydration much more than bacteria can. Hence, you sometimes find yeasts and molds growing on high sugar or salt products where bacteria cannot grow, for example on jams and pickles. Figure 15.1. Principle of osmosis. Look at the screen for table content. Dry salting is used in India for preserving many foods like tamarind, lime, amla, fish and meat. Our pickles also owe their keeping quality partly to the large amounts of salt added. Large amounts of sugar used in making jams and jellies are responsible for the keeping quality of these products. Smoke. Smoke contains preservative chemicals such as small amounts of formaldehyde and other materials from the burning of wood, which are unfavorable to the growth of microorganisms. It is also the heat associated with the smoke which kills the microorganisms and at the time dries out the food, further contributing to preservation. Smoking over a fire is quite effective in preserving certain foods such as meats and fish. Air. Certain microorganisms require air for growth, aerobes, and certain others grow better in the absence of air, anaerobes. It is easier to remove air from aerobes like molds by a wax coating of cheese or by wrapping the food in skin-tight plastic sheets inside which air, oxygen, cannot enter. Chemicals. There are many chemicals that kill microorganisms or stop their growth, but most of them are not permitted in foods since they are dangerous to health. Even those that are permitted to be used as preservatives are regulated by law as to the amounts in which they can be used. This is because higher concentrations cannot be a health hazard. Sodium benzoate is one that effectively inhibits the growth of molds and is used in preserving jams and jellies. Some of the other chemical preservatives used are potassium metabisulfite, sorbic acid, and calcium propionate. Radiation. Preserving food by radiation is the latest technique which is receiving attention over the world. Microorganisms are inactivated to various degrees by different kinds of radiations. X-rays, microwaves, ultraviolet light radiations and ionizing radiations are different kinds that have been used to preserve food. A great deal more work/research is necessary as of now to make this technique universally applicable and acceptable. Check your progress. Exercise 1. 1. Fill in the blanks. A. Most bacteria, yeasts, molds grow best between 16 degrees Celsius to blank C. B. Bacteria and yeasts require blank moisture for growth and molds. C. Dried food get blank if moisture is added because blank start growing in it. D. Blank combined with heat is an effective method of food preservation as it makes the heat even more destructive to microorganisms. E. Microorganisms that require air for their growth are known as blank. 2. Explain the principle of food preservation involved in the following methods. A. Addition of large amount of sugar in jams. B. Placing meat and fish over the fire smoke. C. Wax coating of cheese. D. Addition of sodium benzoate to jelly. E. Blanching of vegetables before freezing. F. Sun drying of raw mangoes. You are listening to this audiobook on Audio Learn IGNOU. 15.3. Home-scale food preservation. All of the processes used for preserving food at home are based on the principles of preservation just discussed. The ones commonly used are preserved by drying and by adding sugar, salt and chemicals. These can be done at home with facilities and equipment normally available in our kitchens. Canning and freezing are possible in the Western homes but not in an average Indian home because the equipment and facilities required are not generally available with us. Preserving by drying. The natural means of preserving foods is available to us in plenty most of the year. There are a large variety of items we preserve at home by sun drying. Some of the very common ones are vegetables, raw mango pieces for making mango powder, papads of all varieties, mango juice, red chilies, and potato chips. The best time of year to sun-dry food items is in the summer, when the sun is hottest. Preserving by pickling. Most of the pickles rely upon salt and the acids of lime, vinegar or tamarind as a preservative. Oil also acts as a preservative by not allowing air to come in contact with the pickle. Several of the spices we use also preserve as well as give flavor to the pickles. The favorite fruits for pickling are raw mangoes and limes. Most mango pickles are oil-based. However, there are some which are dependent only on salt and spices for preservation. Lime pickles may be preserved in oil or just in lime juice with salt and spices. The strong acid of lime coupled with salt acts as a preservative. See Appendix 2 for recipes. Preserving with sugar. As discussed earlier, sugar in high concentrations acts as a preservative. Some of the most popular preserves with sugar which can be made at home are jelly, jam and marmalade. The concentration of sugar in these is 68% or more, which does not allow microorganisms to grow. Jelly is made only from the juice of the fruit. A clear juice extract which contains pectin, complex carbohydrate present in some fruits, is boiled with a certain proportion of sugar, 0.75 to 1.0 kilograms sugar for 1.0 kilograms extract, to a consistency at which it will set on cooling. A perfect jelly should have a beautiful color, should be transparent and firm, and on touching should quiver. It should not be syrupy like honey, or sticky. You should be able to cut it with a spoon and the spoon should come out clean. To get this for jelly making, the fruit should contain a substance called pectin, in enough amount, and a certain amount of acidity. Jams are usually made from the whole fruit, the pulp as well as the juice and quite often the skin as well. The whole fruit, strawberry, gooseberry, or the chopped pulp, mangoes, peaches, apples, of the fruit is cooked with a certain quantity of sugar, 0.75 to 1.0 kilograms sugar for 1.0 kilograms fruit, to a setting consistency. If the fruit is not acidic enough, citric acid or lime juice is added to improve the flavor and the setting property. Fruits good for making jams in India are pineapples, mango, both ripe as well as raw, peach, apricot, apple, strawberry and gooseberry, raspberry. Marmalade is made with the juice extract of a fruit with thin slices of the skin or the fruit suspended in the clear jelly-like mixture. Citrus fruits like oranges are good for making marmalades. Pectin and acid are both essential for the jelly-like consistency of marmalades. The proportion of sugar to juice is the same in a jelly. Preserves or murabbas are made either with the whole fruit, particularly if the fruit is small in size like the Indian gooseberry, or with uniformly cut pieces of the fruit like, in the case of apple. Special care is taken to preserve the shape of the fruit or the pieces. The fruit is preserved in a heavy syrup but the flavor of the fruit is not masked by an excess of sugar. The murabba should be plump, glistering, firm and clear. Recipes for some of these preserves are given in Appendix 2. Preserving by use of chemicals. As discussed earlier, certain chemicals are permitted for preserving foods. The quantities to be used are also regulated by law. Tomato sauce is an example of preserving by heat and chemicals, other being squashes. Squashes are fruit juices preserved by the addition of sugar as well as chemicals. Juices which are sour make good squashes, for example, grape juice, orange juice, lime juice and pineapple juice. When the acid is not enough, you add some, either citric acid or lime juice. Generally, the chemical preservative protects squashes from the action of microorganisms except in the case of the lemon squash. In this recipe, the amount of sugar is so high that no microorganism can grow in it, and, therefore, you do not require either a chemical preservative or boiling. 15.4. Maximization of nutritional benefits at low cost. With increasing population and limited food resources, it is important for us to get maximum food value out of every bit of food we can buy. You can accomplish this by enhancing the nutritive value of foods, by preventing or minimizing the loss of nutrients in food preparations, and by avoiding wastage of food. Let us see how each of these measures operates. 15.4.1 Measures to enhance nutritive value of foods. 80 Sprouting, fermentation and combining different foods in a meal are ways to get the maximum nutritional value from some of our foods. You are already familiar with these processes. Let us talk about each of these in some more detail. Sprouting. Dry pulses and grains do not normally contain vitamin C, but when they are allowed to sprout or germinate, vitamin C is formed in the grain and in the growing sprout. Sprouting also increases the content of B vitamins present. As you know, sprouting involves soaking the pulse or grain in water for 24 hours and then wrapping them in a damp cloth. In 2 or 3 days the grains germinate and the sprout grows to a size of 3/4 of an inch. You must keep the wrap damp all the time. The germinated grain can be eaten raw or after cooking for a very short time so as not to destroy the vitamin formed in it. The grain commonly used to sprout is Bengal gram. Even better than Bengal gram is the whole green gram, moong dal. Sprouted green gram contains 3 times more vitamin C than sprouted Bengal gram. This is an excellent example of how one can get maximum nutritional benefit from a food item using very simple and inexpensive techniques. Fermentation. Natural fermentation in food occurs when environmental conditions permit interaction between microorganisms and the food substance. Fermented whole wheat flour is used to make bhatura or naan, deep-fried small rounds made from fermented wheat dough, and the fermented dough and idli mixtures are examples of natural fermentation. The process of fermentation encourages the multiplication of specific microorganisms and their metabolic activity in food. This is what we do when we turn milk into curds. We encourage the multiplication of the lactic acid bacteria in the milk. If you see curds under a powerful microscope, you will find it crawling with these bacteria. The significant point is that several of the end products of such food fermentation, particularly the acids and alcohols produced, do not permit the growth of pathogenic, disease-producing microorganisms that may find their way into foods. Fermented foods often are more nutritious than their unfermented counterparts. This is because of 3 reasons. One is that microorganisms not only break down more complex compounds, they also synthesize several complex vitamins, for example riboflavin, vitamin B12 and vitamin C. Therefore, the content of these vitamins in fermented food is also higher than in their unfermented counterparts. The second way in which fermentation enhances the nutritional quality of a food is by liberating nutrients locked inside the plant structures and cells by indigestible materials. This is especially so in the case of grains and seeds. The milling processes do release some of the carbohydrates and proteins by rupturing the outer hard covering of the grain. However, coarse milling as practiced in the villages is not enough to release the full nutritional value of such plant products. Even after cooking, some of the entrapped nutrients may remain unavailable to the human digestive processes. Fermentation breaks down the indigestible protective coating and cell walls both physically and chemically, making the structures more permeable to the water of cooking as well as to man's digestive juices. A third mechanism by which fermentation enhances nutritional value, especially of plant material, is by splitting cellulose and hemicellulose, i.e. fiber that man cannot digest, into simple sugars, which can then be utilized in the human digestive tract. A large variety of fermented food products are made use of by people of different nations the world over. Some of the ones we are familiar with are curd, buttermilk and coffee beans, all made with the help of lactic acid bacteria, wines and vinegar made by bacteria producing acetic acid, beer, rum, whiskey, brandy and bread made with yeast fermentation, cocoa made by yeast along with acetic acid producing bacteria. Food combinations. You have already studied the importance of proteins to the human body, and the fact that cereals or pulses taken by themselves cannot provide our body with adequate proteins. One or the other essential amino acids would be lacking. Unit 3, Block 1. If, however, we consume a judicious combination of pulse, cereal and other plant foods, the net quality of proteins we receive would have the desired pattern of essential amino acids. The proteins of cereals and pulses have a natural supplementary effect, and a deficiency of an amino acid in one food item can be made good by an excess of the same in another, if both foods are consumed at about the same time. Some of our traditional dishes like idli sambar, rice dal, chola bhatura, khichdi, dal roti, pulihora, bisi belahuliana are some of the examples of such nutritionally beneficial combinations of foods. You can find some more in the area you live. Many nutritionally beneficial combinations for infants, growing children and pregnant and lactating mothers have been worked out by agencies and organizations interested in improving their nutritional status. You have read about some of these ideas in Block 3. Fortification. As you know, fortification is a technique to add nutrients to a particular food item. Nutrients chosen for fortification are those that are likely to run into short supply because of either dietary habits and prejudices, or due to the inability of the people to purchase foods that contain them, or because of the foods that are supposed to contain them do not do so in a particular area. Another criterion of selection is to be able to mix a nutrient with food without affecting its acceptability, and the overall cost of such fortification. Food items selected to be fortified are those that are consumed by the largest cross-section of the population. Examples of fortification in our country are vitamins A and D in hydrogenated fats, and iodine in common salt. 15.4.2 Minimizing and preventing nutrient losses in food preparation. The food that we prepare should be palatable as well as nutritive. Neither of these qualities can be sacrificed at the cost of the other. However, accomplishing a correct balance is not an easy task. There are certain facts we must keep in mind, and certain general rules that we must follow to come as close to a perfect balance of nutritional quality and palatability as we can. Some of the vitamins, the water-soluble ones, are easy to lose. They get lost in the water we use for preparing or cooking, by exposure to sunlight and air, and by prolonged heating. Some of the rules to observe in processing and cooking foods so that there's minimum loss, if any at all, of the nutrients in our foods are as follows. A. Wash vegetables before cutting. B. Cook vegetables on low flames with as far as possible no water and keep them covered while cooking. C. Do not overcook. D. Cook rice in just as much water as it needs to cook. Do not use extra water which needs to be thrown away. E. Cut fruits just when you are ready to eat them. F. Use acid foods, such as lime juice, tomatoes, vinegar, or curds in salads. It helps to retain the vitamin C value of the salad item. For more details on this aspect, you can refer to the Practical Manual. I. Section 3. Figure 15.2 shows various preparation and preparation methods generally adopted while cooking meals. Some of them are wrong and others are right. Tick mark on the right methods. Figure 15.2. Find the right procedure of cooking meals. Look at the screen for table content. 15.4.3 Measures to avoid food wastage. Wastage of food can occur at any stage of operation, from harvesting of food material to its consumption. As already mentioned, almost 10% of our cereal crop in this country is wasted at the farm level. If this is so with non-perishable crops, the wastage must be very much higher in the case of semi-perishables and perishable food items. There can be wastage of food at two stages, at the level of producer and at the level of consumer. The following flowcharts explain possible points of wastage in both of these stages. Points of wastage at the level of producer: farm, transportation, sale, distribution, go-down/markets, where the food item to be stored, sold or distributed. Points of wastage at the level of consumer: preparing the food items for processing/cooking, serving the food to family members, use of stored leftover food items. We as consumers have very little control over methods adopted to eliminate or minimize wastage before the food comes to us as a commodity we have purchased. However, from that point onwards, it is in our hands to prevent any further wastage. Let us dwell on these points. In Block 3, Unit 7, you have learned how to make judicious use of leftovers in order to avoid wastage of food. Can you think of some other measures which you would like to adopt in order to avoid wastage of food at home? You may find the following suggestions useful. A. Plan meals in advance for at least 1 week. Plan your meal preparation for the week, keeping the meal plan in mind and vice versa. For example, if you have Shrikhand on the menu one day, you can plan to serve lassi, curd whipped with a little water, the same day or the next, making use of the liquid that will drain out from the Shrikhand, thus utilizing a nutritious byproduct. B. Use the leftovers as early as possible. C. Check your store to see what is already there before you make the market list. Use food items that are likely to spoil first. D. Buy the correct amount needed, thus being assured of enough food for meals and no food wastage. Particular attention must be given in this respect to foods that cannot be stored adequately by you and must, therefore, be consumed. E. Review your next day's meal plans at the end of the previous day so that, if necessary, you can alter them to take care of any new developments in your family's plans or to use the leftover foods you had not expected to be there. Check your progress exercise. 2.1. Give the name of the preservative commonly used in making the following products. A. Orange squash. B. Mango pickle. C. Guava jelly. D. Tomato sauce. Mango powder. 2. How is fermentation of food products beneficial? 3. Comment on the following statements. A. Sprouted green gram dal is more nutritious than green gram dal itself. B. Some of traditional food combinations like idli sambar, rice dal, roti dal are nutritious than individual dishes like idli, sambar, rice dal. C. Iodine is added to salt. D. Rice should be cooked in just as much water as it needs to cook. You are listening to this audiobook on Audio Learn IGNOU. 15.5. Let us sum up. In this unit you have learnt that preserving food is an important aspect of making available food last longer. Food can be made to last longer by either slowing down or completely stopping the growth and activity of microorganisms and the naturally inherent enzymes in the foods, or by completely destroying them. Every method of preserving food also has harmful effects on the quality of food, particularly on its appearance and nutritive value. Methods are available by which the nutritive value of certain foods can be enhanced without any much cost. 15.6. Glossary. Bacterial spore. Spores are hard resistant bodies that are formed by some kind of bacteria when conditions become adverse for surviving. Canning. Canning here refers to the method of preservation of fruits, vegetables, meat and meat products in sealable cans. The process involves placing of blanched fruits and vegetables in the can, closing, heating of the can and then cooling it. Carbonated, addition of carbon dioxide. Cellulose, a complex carbohydrate that cannot be digested by man. Decomposition, a process of decay or spoiling. Inactive, to put out of action. Palatability, ability to stimulate a desire to eat. Pathogenic, disease-producing. Pectin, a class of complex carbohydrates present in some fruits. These help in the setting of jellies and jams. Sterile, totally free of microorganisms. Thank you. We will see you in the next video.